All right, here's our last example that we're going to show right now. This is from the 5.1 homework. This is number 14. I picked it because the original system of equations has fractions. Just double checking that I copied it right. Yes, so it's x over 7 minus y over 7 equals -1. This is my version of this problem. Yours will be different probably. And then my second equation is x plus 2y equals -13. So just a reminder about clearing fractions, which is really what we probably want to do for that first equation. Whatever your common denominator is, just multiply your whole equation by that number. So for that first equation, before I even think about elimination, let's just clear those fractions. So I'm going to multiply that whole equation by 7. And when I distribute the 7 times x over 7 will just be x now, because the 7's cancel out. 7 times y over 7 is now just y. And then I need to continue distributing to both sides. 7 times -1 is -7. So that's now my rewritten first equation. And then we can just copy the second one. That doesn't have any fractions, so I'll just rewrite it. And then from there, you kind of use your usual procedures for either using substitution or elimination. The directions for this one say solve by the method of your choice. So you get to choose. Substitution would work okay. If you wanted to maybe isolate the x in the first equation, that would work fine, or even the second equation. Or maybe you notice the x's are lining up with each other, and maybe you want to multiply the second equation by -1, or the first equation by -1 to eliminate the x's. So we have choices. Solve by the method of your choice. I think I've shown more elimination than substitution at this point. So just to make sure we have another example with substitution, I think that's what I'm going to choose here. So if I choose to do substitution, I'm going to isolate x. Because in both equations, x has just a 1 coefficient. I'm going to choose the first equation. If I isolate x, I can solve for x by adding y to both sides of that equation, and I would get x equals y minus 7. Because if I do plus y on both sides, I would end up with positive y minus 7. And now I can substitute into that other equation. So I can replace x with y minus 7. So it becomes y minus 7 plus 2y equals -13. And now I can solve for y. So elimination would have worked great as well. It really doesn't matter. Solve by the method of your choice. So I'm going to keep going. I substituted for x. Now I'm going to solve for y. Combine like terms. Y plus 2y is 3y. 3y minus 7 equals -13. Add 7 to both sides. You get -6. Divide by 3. Y equals -2. Now I go back and find x. I'm going to use the equation where I got x by itself. X equals y minus 7. Replace the y with -2. X equals -2 minus 7, which would be -9. So the answer that I just got is -9, comma, -2. Okay, so there's our solution. And now we really should check this one, especially because it was a little trickier at the beginning. So I am going to go back and check it in both equations. So I'll pause, erase, check, and then we'll be done. Okay, we're about to check our solution. We had gotten -9, -2. So let's first check in the first equation. It was x over 7 minus 9 over 7. See, I can't talk and do this at the same time. Let's try again. X over 7 minus y over 7 equals -1. Replacing x with -9, replacing y with -2. Okay, let's try that. So instead of x over 7, we're writing -9 over 7. Minus, instead of y over 7, we're writing -2 over 7. Equals -1. So now we're checking, we're assuming it's going to work. Let's see if it does. -9 minus -2 is really the same thing as -9 plus 2. Those are both over 7. Common denominator is already there. -9 plus 2 is -7. And yes, -7 over 7 is in fact equal to -1. So our solution does work in the first equation. Let's now check it in the second equation. So x plus 2y equals negative 13. X plus 2y equals negative 13. So I just replaced x with negative 9 plus 2. I'm now replacing y with negative 2 equals negative 13. Let's check it. Negative 9 plus 2 times negative 2 is negative 4. And yes, that does add to negative 13. So it checks out. Okay, so that's all we have for our take-home notes for section 5.1. We've seen the examples in the PowerPoint. You've seen a couple of homework examples. We're going to build on these concepts for the next two sections. So section 5.2 is systems and 3 variables. And then section 5.4 is nonlinear systems. So systems like this, except they're going to have x squared or y squared or x to the third. And so the solutions will be a little more complicated, but the procedure will be similar at the beginning. So keep in mind, sometimes you'll need to use elimination or the addition method. Sometimes you'll need to use substitution. So it's important to know both. Okay, that's all I got. So you know how to reach me. Let me know if you have any questions, and good job.